At many work sites, grapples do all the heavy lifting. Dangling from crane booms, these huge mechanical claws move mountains of materials, one load at a time. Some are equipped with powerful electromagnets, helping them get a good grip of the situation. Not much can escape the grasp of the mighty grapple. A magnet at the center pulls metal from the scrap heap, while 4 fingers dig into the pile. It then transfers the load of steel for recycling. It actually takes some of that recycled steel to make a grapple, in the form of steel plate. A computer-guided flame burns through steel to cut out the various part shapes. It will take approximately 50 pieces in a range of shapes and thicknesses to make one grapple. A press brake repeatedly rams one of the parts, while an operator adjusts it forward between thrusts. The process curls the part to give it a claw-like profile. It's the basic shape of a grapple finger. Using a template, he checks the curvature to confirm it's on target. He'll curl 4 fingers per grapple. Meanwhile, a welder pieces together the grapple's core, working within a special fixture that allows him to assemble it precisely. After he tack welds them together, it's over to the robot. It does the permanent welds as the core slowly rotates in a special device. They hoist the welded grapple core over to the magnet and feed its main wire up through the core. They lower the core and it fits onto metal dowels protruding from the magnet. This allows them to align the two precisely. They thread high-strength bolts onto the dowels to secure the assembly. Next, they place a turntable bearing on the grapple's top flange. This bearing is an important part of the claw rotator mechanism. They fasten the bearing's outer ring to the flange with numerous bolts, torquing each one tightly to withstand the spinning action of the bearing's inner ring. As demonstrated here, the bearing turns in both directions to give the grapple claw's movements flexibility. A worker now lowers the upper rotator assembly onto the turntable bearing. This assembly holds the rotator's motor and the manifold that feeds hydraulic fluid to the cylinders that power the claw. They now slide the hydraulic cylinders into their slots and lock them in place with pivot pins. They install a total of 4 cylinders. Each one will power 1 grapple finger, and together they'll open and close the grapple claw. They connect the hydraulic feed lines to the cylinders and reinforce the connection with a 4-bolt flange, which can handle the pressure of the hydraulic fluid. They guide each steel finger into slots in the grapple core and align them correctly. They slide a pivot pin into the attachment holes to link the two. This pin will also act as a hinge as the finger opens and closes. They fasten the pivot pin to the grapple with a nut that's split in one spot. This split enables it to be squeezed tightly around the large pin using a small bolt. They attach the hydraulic cylinders to the claw fingers with more large steel pins. They're now ready to power the grapple claw and test the gripping action. The 4 tines, or fingers, open and close in unison. The tips mate correctly. There's no overlap. This grapple claw is now ready for the job site. It weighs 4.5 tons, and just dropping it on a car will crumple it like a piece of tissue paper. It takes about 150 hours to manufacture a grapple claw, and when combined with a magnet, it's got a strong hold over anything. Hold on a minute, that's my car. Put it down. Ugh.